Hi my friends, today we try to model this impressive building in Chicago, United States. We have some data from Wikipedia and we can see that we have 9 pillars of floors and we want to obtain this model in Inventor. First, let's see more about this building. We use Google Earth and we go from Romania to Willis Tower, Chicago, Illinois, USA. Go. We go over the Atlantic Ocean to the Michigan Lake, and here is building. You see, it is very impressive because 25 years this was the highest building in the world. 25 years. Before this was the famous World Trade Center in New York, and after this was Petronas building in Kuala Lumpur, Malaysia. I visited this building and I have very nice remembers about it. It has 4 decks, this building. These are the decks, and you can go outside the building in one of these 4 decks, and these decks are at the floor number 103. An interesting thing is that when I went there I saw a very interesting building here, right here. Yes, you see, when you are at this level, the floor 103 is only for visitors. The elevator takes you with the speed of 10 floors in 5 seconds. That building, this one, is an interesting building because it has windows, very thin windows. What is this? And when I went in 1999, I saw here some people who were playing basketball. I asked a guy about the building and he says, "This is the Metropolitan Correctional Center in Chicago and Federal Bureau of Prisons." This is a prison, my friends. You cannot go outside. Let's go back to the building. As you can see, there are 9 pillars of floors. This is the first one which has 50 floors, and the other one, an opposite one, is also 50 floors. This is 66, this is 90, and this is 108. There are also another 3 floors at the basement, which is larger than this ground area. It means that the whole building has 111 floors. Each pillar of floors has a square section with the side of 75 feet. The height of the building is 1,451 feet. In meters, this is 445 meters. Let's take a look at some pictures to have an idea about this situation. This is the building itself, which has a railway for the train which goes in front of the building. This is what we want to obtain, and this is the construction. 2 pillars of 50 floors, other 2 of 66, other 3 of 90 floors, and these 2 of 108 floors. They compound the building, and you have a simplified cross sections of each floor. I counted the floors, and from the above the basement to this gap without glasses, we see 28 floors. Then from 28 to 32 are floors without glasses. We call them a gap. It goes to 50, then to 66, then 90, and then the last 108. I made this picture with all that 108 floors. This is 28, this is with 4 floors, then 18 floors, then 13 without gaps like this one, then 2 floors without windows, another one with windows, and then we go here. This is 66, yes, 66, 66. Then we have 21, then 2, then 1, then 13, and 5. Total of 108. This is the placement. The north is this, and the streets around are Walker Street, South Walker Street, Franklin Street, Jackson Boulevard, Adams Street. And this is the data when I made this model in 2015 on GrabCAD. And this is the calculation. The architecture is 1,451 feet. The floor count is 108 plus 3 basement. This means 111. And we can calculate the height of one floor, 13 feet. Yes, we will use this because we don't want to make something very specific. We simply want to create this 3D model. Let's see how can we create this building. Well, this is what we want to create. Yes, I made this. I placed the direction to north, which is opposite to axis Z. I also made a drawing for antennas. You have seen that antennas, and you see how big they are. This is with the millimeters as unit, 5 meters is the diameter of the base cylinder. The height is 78 meters and the other is 85 meters. You have here all the necessary data in millimeters. For the floors we use feet. Yes, 1 foot is here. Yes, 1 foot is 300 millimeters or 12 inches. 1 inch is 25.4 millimeters. In Inventor there is no problem to use this measure as well as millimeters, and you will see how easy it is to do this. Okay, you see each pillar of floors, and if you take a look very careful to one of them, we see a pattern. Yes, a horizontal line and 4 vertical lines, and this is in order to obtain the same aspect as we saw in the real model with Google Earth. Well, let's start with the construction. New standard millimeters, you see, a sketch with Z on vertical. We place the base square. You see, we have millimeters. And now I write feet, 75 ft. Tab 75 ft. Home. I place dimensions in feet and we have results in millimeters. I don't want to say feet and to see millimeters. Let me change the background. Alt F(I) in succession, and we have the application options table. Colors, presentation, apply. I said we don't want to see millimeters when we place their dimensions in feet. To clarify, I go to Tools, Document Settings, Units, and I change here millimeters to foot. Apply. You see, now we have 75 feet. Finish sketch. Extrude, and here I place the height of the building 1451. Okay, this is the first pillar with 50 floors. I change the color of this object from default to white. you'll see why. Now I think that this is too height. Let me see, what is this? Oh, not 1451, but 13 feet multiplied by 50. Yes, this is the right proportion. Once again, double click. You see we have 13 feet multiplied by 50 unitless. 50 is abstract number to multiply the floor height. Good. Now we create that pattern, but I'll call it as grid, not pattern, because pattern is this rectangular pattern. I don't want to make mistakes. Good. Let's take a look to the picture, and we see the first set of floors is 28. Then comes this gap, 28. Take a look at my procedure to know what I do here. I create a sketch, a line as construction line, horizontal, with a length of 75 what? Feet, of course. Not construction, and then I draw a rectangle with a length of 75 minus 2 tab on 1 feet height. I place on the same vertical this midpoint with this midpoint, and the distance between this line and the upper side of the rectangle must be 4 inches, not millimeters, not feet. If I write here 4, this will be 4 feet, so that I have to mention the unit, inches. Good. Then I draw another rectangle based on this line with the width of 1 foot. Now I apply the distance, the dimension between this line and this point of 13, because this is the height of a floor, about 4 meters, around 4 meters. And now I make something unusual. I delete the upper end of this rectangle. Take a look at the 3 constraints which will disappear. Delete. Now I have to compensate somehow that constraints. Look here, if I move something, everything is moved. So I apply perpendicular between this and this. I apply parallel between this bottom line and this line, and I apply equal to the left and right ends, sides. Now we have 3 dimensions needed. Yes, of course, 2 dimensions are for placing this sketch somewhere, horizontal and vertical, and another one is the placement of this rectangle. We start with this, with rectangle. The distance between the midpoint and the end point is 75 divided by 5, because this is the step for my grid. Then I apply a rectangular for this geometry of 3 lines. On the horizontal direction to the right, with a distance of the same 75 divided by 5, but with 4 instances here. Okay, now we have this nice grid. I want to have only one closed area, so that I split this line to create segments and to apply construction for each one. Yes, now I keep pressed the key Shift and I select each segment and I make it, all of them, construction. Now if I want to select an area, I have only one selection to do or to make. Good. Finish sketch. I change the name of this sketch in grid unit. I want to use another name instead of pattern, because pattern is a tool in Inventor. And now I place the sketch at the position with constraint this endpoint to this line and collinear between one horizontal, this horizontal, and the bottom here. Now we have a dimension of 13 to be placed here, which is from the bottom of construction to the construction line. Okay, finish sketch, apply extrude, select what to extrude. This is what I want to extrude, with cut, not join, and not to through all the part, but only on 1.5 inches. Yes, this is another important dimension. Now I can change the color of the external faces. Bottom face, I keep shift pressed, and all three rectangles here to make them black. Black. Now, as you can see, we have white for anything we do further, but this is black. Why black? Because the Willis tower is black. Another important thing is to share the sketch. Share sketch. Yes, we placed it here after the first feature to use it all over without looking for it in some features and so on. Good. What next? Next is the multiplying in 28 instances of that grid from the bottom. 28, then a gap of 4, then 18 to reach the end of 50 floor pillar or cell. Pillar, I call it pillar. Keep in mind 28, 4, 18. This extrusion must be multiplied in a rectangular pattern on this direction up 28 times at a distance of a floor, 13 feet. Okay, now I want to place here again this sketch, but at a distance of 4 to create a gap. The distance is 5, not 4, because I place this here. I apply copy, I apply sketch, I wait a little, and I paste the sketch somewhere here. Okay, then I move it up. Oh, what is this? Oh, finish sketch, Control Z, Control Z, Control Z, Control Z, because I have to edit this sketch, eliminating the yellow lines. Delete, finish sketch. I want to see what happens here. It also have that yellow lines because I keep set something in the options. Once again, copy this grid unit, copy, face, sketch, paste, and now this end will be on the left side of the building, and I move up the sketch. Let me make it more visible. Now you see better. What distance? I told you 5 from this construction to not from this construction, from the top normal line to top normal line of 5 floors, not 4. This is 13 multiplied by 5, which is 65. Okay, finish sketch, extrude. This is to be extruded, and now we have 1.5 inches. But what is the direction? Direction must be to cut. Okay. 18 is the next value, yes? 28, 4, and 18. Rectangular pattern, last feature, direction up, and 18 with a distance of 13 feet. Okay. Now we must be right here with a distance of 4 inches. Let's measure. M for measure. From this line to this line, and we have really a third of 12. Good. We save this object as P50. Okay, P50 is pillar of 50 floors. Save. Now I go to the next pillar. The next pillar is 66, but it contains all the grids from here. I forgot something. I want to mirror the corner grid. Look, I create a plane by using this edge and this edge. Then I apply mirror for all below the first extrusion, all this. You see, I want to mirror all this about this plane, and we have two faces with grids. This is important. I save it as P50, and I also save as P66. Save as P66. Why? Because there is identical space between the two bodies. I modify for the 66, I modify the number of times to create the pillar of 66. Then we see that we have to add 13 floors, 2 floors for a gap and another one at the end to obtain 66. Yes, 50 plus 16 is 66. Good, keep in mind. So now we know the procedure. We copy the shared sketch, we select a new sketch, we paste we wait for a while, paste, then coincident this point and point with the left side, and the distance is 13, my friends. 13 is the distance between this line. Once again, I want you to see better. Distance between these two is 13. Then we exit from the sketch. But what is this one dimension needed? What dimension is this? I don't have any idea about what means this. I cannot move anything from the sketch. Maybe it's an object outside of our interest. Finish sketch, extrude this. Now we place here 1.5 inches as select all 1.5 inches to the inside. It's very delicate, and you have to be careful with everything here. Then 13, yes, 13 of the last feature to this direction, 13 of 13s. Okay. then once again we copy the shared sketch, we select the last face here, we wait a while, and we place the sketch. The left point is placed here. We move the sketch up and up, to a distance of 3, because 2 is the gap. Dimension between this line, not construction, this to 39. And now we are up. Finish sketch, extrude, (1.5) as cut. Okay. Now I wonder why. I don't wonder. That's all correct. Good. I have to mirror this last constructions so that I apply mirror about the same plane. It was not forgotten. No, I don't mirror the plane. I mirror the extrusion, the rectangular pattern, and the extrusion about this plane. Okay. Now the pillar 66 is done. I save it under the name P66. Yes, the name was already placed there. And now I save it also as 90. P90. Which is now changed, not 66 but 90. We go back to the drawing, to the image, and we finished this. We apply 21, gap of 2, and another 1. 66 plus 24 is 90. Okay, you know the procedure. But now, since we already have this grid, yes, from the previous construction, we have to number 22 instances, not 21 up, because this is here and we use it for the next sequence of floors, so that I apply rectangular pattern for this existent, not new, grid, and direction up. One is from the past plus 21. The distance is 13 feet. Okay. Good. Now a gap of 2 and only one grid. The procedure is that we already used. Copy, sketch, copy, sketch. Wait for a while. Then paste the sketch, paste. We move it somewhere here. Coincident this with this line, and the distance between up to up of 13 multiplied by 2 plus 1, because we have to count also this existing. Okay. Not good. Not 1. This must be a parenthesis, like this. 2 plus 1. Yes. 2 and 1 are both unitless. Okay, that's good. Finish sketch. Visibility, because we apply extrude 1.5 in the other direction, or cut, not join. Okay, good. Now we apply mirror as before of that new grids. Mirror of last extrusion, rectangular, and the mirror plane is work plane, and we have this final. The problem is that we have to place also here grids. Take a look at the model. We have from 66 to 90, we have this and this, so that we have to mirror, because we don't know where this comes, here or here. We have to place from this level mirror on both sides. Yes, you understand me. Mirror. Let me create the plane before. The plane is based on these two edges. A new plane. Now mirror of this, and also these two. Yes, about this plane. Okay. Hide this plane and we save as P90. Save. We also save it as P108, my friends. Save as P108. And we extrude the end to not 90 but 108 unitless times. One, 8. Okay. Good. I save it to be sure. Let's see what's next. Next, these two are finished. We'll reuse this to this 13 plus a gap of 5. Yes. Okay, let's do this. We apply rectangular pattern on this last grid, direction up, number 1 plus 13, the floor height is 13 feet. Okay, we can measure the distance here, which must be 65 feet from this line to this line, plus 1/3. Yes, 65 plus 1/3 foot. Okay. In order to have grids on all faces, we apply mirror for this last rectangular pattern about this plane, which is this one, but not selecting now. Mirror features are regular patterns, rectangular patterns and mirror plane to be this one. Okay. To place them also on the other faces, we don't know which of these pillars are in front or in back, so that we apply mirror for rectangular pattern and mirror. About the other plane, mirror plane is this one. Okay. Now we have all pillars. Let's save the last one and we go to model the assembly. Before we create a new component, which is a simply sketch. The sketch is the base of the building. I create a rectangle with two equal sides and the dimension in millimeters, and I want to be in feet, so that I add this suffix feet. Let's modify the units. You know the procedure to be foot. Okay, and we have 75 the dimension. Then we multiply by using the rectangular pattern. The geometry is this direction is to the right, 3 of 75, then the other direction, which is also 3 with 75, but once again direction 2 is reverted. Okay, finish sketch. No dimensions visible, and we have this is the center point. We have the base of building. Let's save it as base. Base. Good. Now I close all that and I create a new assembly. Assembly which is based on base, grounded at origin, one instance, and then place the two 50 floor pillars. As you can see, they are in the corners. I apply constraint with this face on the plane XZ. Yes. Apply. And the other one is the same on the plane. Apply. I move one right here and I apply constraint of this edge with this line. Apply and also apply this edge with this line. Apply. The other must be reverted so that I select this to be here. Not good. Cancel. I rotate manually, free rotate this object to be somehow like this. Then I constrain the edge with line, apply, and the other edge with other line. Okay. To have a better vision, I change this to be presented in perspective. Yes. These are the first two smallest pillars. Place P66, 1, 2. Then constrain face to plane, apply face to plane, apply. Now I take a look at the orientation of these two. Yes, this must be oriented with this edge on this edge. Apply. And this one with this one. Okay. The other one. The other one is somehow the same. Edge to edge. Apply. And then edge to edge. Okay. Good. We look careful to have to the inside black faces. Yes. Next we have to place these 3 of 90 floors, 3 pillars of 90 floors, but not this placement, but this one. You see, 1, 2, and 3. Good. Place P90, double click, 1, 2, 3. Constrain. Face to plane, apply, face to plane, apply, and face to plane, apply. Okay, now I move them in other positions to see how to be placed. You see, this one must be placed here, and this one somewhere here, and the last in this position. Good. We are looking at the grid faces to be respected. This is not well. Yes, we have to rotate it. Rotate, free rotate for this one to be with this face to the inside. Yes, now I can orient them with this edge on this edge. Apply internal with internal black faces. Apply. The other one was well placed here, so that I select this edge to be on this line. Apply, and gap on gap, and these two are okay. Apply. What about the last one? The last one must have this to the inside. So I select the edge and the line. Apply. Good. Very good. The last is contact on internal faces. Okay. The only mistake is that this must be placed here, because we use Z as north, and as you can see here, these two must be oriented to west. This is west, X is west. No problem. We go back and we select this component, and we eliminate 1, 2 mates, constraints, delete. Now I can move it where I want to be. I want to be here, not here, but I have to rotate it so that this face to be to the inside. Free rotate this object, selected, you see, selected, free rotate, and we rotate it 90 degrees about. 90 degrees. Good. Now I place this edge on this line. Apply. And this face to be in contact with this face. Okay. Now I see that the two places for the tallest pillars to be oriented to the axis X. And now the tallest pillars, P 108, 1, 2. First place the basement, not place, constrain base to face, apply, or face to plane, I said before, apply, cancel. I get them out. I take a look to the black faces. Black faces are these two. Constrain black to black. Apply. Then align these two. Apply. And now everything is okay. I place on the face this or this. Yes, this one. Okay. We have the building, my friends. Very interesting. The last thing to do is to place antennas. You have here the drawings and you can model them very easily, no problem. I don't model these two objects. Antenna east will be to the right, antenna west will be to the left. Place antenna east to the right, escape, blank, antenna west to the left. Now I change the background, Alt F-I in succession, and we can use application options to change on dark. Okay, now we see antennas. I don't want to see this basement, so that I may apply click and Alt V, visibility. Alt V, combination for hiding objects. Good. We have to place antenna up there at the 400 meters altitude. Yes, we will place them there. Constrain, face to face, apply, and face to other face, apply. We want them to be placed in the center of each face here. We create some work entities. Double click on this and I create the axis at the intersection of these two planes. 1, 2. Both pillars receive that axis. Yes, because they are identical. Okay, now constrain any segment of this antenna on the axis. Apply. Any segment to axis. Apply. Then I go to that components to apply not visible. Now you see they are both not visible. Oh, not both, because they are different now. They are different. P100, P90, and I double click this one. I select the axis, Alt V. They are not visible, but they are there. They are not missing. Now we have a very well presentation of the building. Oh, this is not finished. Let's make them to be together. Constrain this face over this face. My mistake, my friends. Nobody is perfect. Good. Now I think you see what I see. I want you to find out a trick now. You see, this is a perspective presentation. If you select this view, you can apply a forced perspectiveness. How can I call it? You have to press both keys, Control and Shift. I have pressed now together, and then you rotate the wheel of the mouse and you force. You see, look, this is reverted perspective, and this up is a forced perspective to have some other images of the object. Yes, you can use environments and Inventor Studio to create a better presentation. I have no time to do this. Try for yourself. You have some tutorials made by me, and you can use them to make anything you want. That's enough for today, my friends. It's such a long lesson, this, but I hope you will enjoy to model it, or at least taking a look to the procedures and this tutorial. Thanks for watching. Bye bye.